Okay, we are going on with complex numbers, and in this video we'll focus on working with conjugates. So this is a simple video where we just revise the basics on what a conjugate is and how we can work with it. So let us consider a complex number of z, where z is equals to a plus bi. Now the conjugate of z would be noted as z star, and that conjugate would be a minus bi. Let's say that z is equals to 3 plus 2i as our complex number. Then the conjugate of that z would be 3 minus 2i. So let's see what happens if we add a complex number to its conjugate. That will be a plus bi plus a minus bi, which is simply equal to 2a. Or a practical example, we have 3 plus 2i, and we add its conjugate, which is 3 minus 2i, and that is equal to 6. In our second example, let us say we have a complex number, and we want to subtract its conjugate from it. So that will lead to a plus bi minus, and then in parentheses, a minus bi. And when I simplify, that will be a plus bi minus a plus bi, which is equal to 2bi. So let us look at a practical example again of subtracting the conjugate from a complex number. So we have 3 plus 2i minus 3 minus 2i. And when I simplify, it will be 3 plus 2i minus 3 plus 2i. So remember the sign change, and that leads to 4i. Notice it's not equal to 4i squared. We are simply adding the coefficients together. Let us see what happens if we multiply a conjugate with a complex number. So in this example, it will be a plus bi times a minus bi. And when I simplify, that leads to a squared minus b squared I squared. But remember that I squared is equals to negative 1, because I represents the square root of negative 1, and when I square that, it leads to negative 1. So if I simplify further, I have a squared plus b squared. So let us look at our example again. We have z times its conjugate, where z is 3 plus 2i times 3 minus 2i. And when I simplify that, that leads to 9 minus 4i squared. And if I simplify further, it becomes a real number where it's simply equal to 13. Remember that I squared is equal to negative 1. So it's 9 minus 4 times negative 1, which is 9 plus 4, and that becomes a real number of 13. And lastly, let us look what happens if we divide a complex number by its conjugate. So that will be a plus bi divided by a minus bi. But remember, in order to simplify this division, I need to multiply the numerator and denominator with the conjugate of the denominator. So that will be a plus bi. So in effect, I'm multiplying the numerator and denominator with the conjugate of the conjugate, which is the original complex number. So let us again look at our practical example. Here we have z divided by its conjugate, and that will be 3 plus 2i divided by 3 minus 2i. And in order to simplify this fraction, I would multiply both the numerator and denominator by the conjugate of the denominator. So that is 3 plus 2i. And when I simplify that, remember, I simply need to multiply out the parentheses, as I would do normally in algebra. So in the numerator, I have 3 times 3, which is 9, times 3 times 2i, which is 6i, plus 2i times 3, which is 6i, plus 4i squared. remember that I squared becomes negative 1 over 3 times 3, which is 9. And then the middle terms will cancel out. So it's minus 4i squared. And if I simplify further, I have 9 minus 4 plus 12i, where the minus 4 comes from 4 multiplied with negative 1. So it's 9 minus 4, and then 6i plus 6i is 12i. And in a denominator, I have 9 plus 4, where negative 4 times negative 1 becomes plus 4. So if I simplify, I have 5 plus 12i over 13. So there we have it. We have learned what will happen when we add a complex number with its conjugate. Also, when we subtract them from one another. I also showed you what happens if we multiply a complex number with its conjugate, and also when we divide it with its conjugate.